This video is going to help you hopefully figure out how to graph linear equations and review some things about the coordinate plane, and also, if we can get there, maybe not in this video but the next, just by looking at a line we can be able to write equations. So let's see what happens here. First of all, this is our coordinate plane. If you remember, this is the x-axis, or the horizontal axis, and it runs from left to right, and it looks just like a number line, and it acts just like a number line. Here's the origin, and it starts at 0, and numbers to the right of 0 are positive, and numbers to the left of 0 are negative. If you were to flip that 90 degrees, turn it on its side, you would have the y-axis, and likewise it goes up in the positive values and it goes down in the negative values. Coordinates are listed as pairs, so if we want to talk about a specific location on this graph, we need an x coordinate and a y coordinate to take us there. Real quick, I'll get rid of the graph for a second here and talk about coordinate pairs. So we always have an x value that lays on the x-axis and a y value that leads us in the y-axis. So, for example, if I want to find the location that's at -2, 4, I can get my graph back here. And I could put -2, so I need to find -2 on the x-axis, that's right here. So we count back, but don't put anything there yet. We need to wait till we get to the 4, so we're going to go up 4 once we get to -2. And right here is our final location. That's where we need to draw our dots. So we don't really mark anything right here. We just put that dot there. And that location is a point. Remember, points are named with capital letters. And then if we have enough room, usually we want to list the coordinate pair just to be absolutely sure we're talking about that one. Let's talk about another point here. Let's say I want this point right here. We'll call that point B. And if I want the x value, well, I count over where it meets up with the x-axis. That's at +2. And where it meets up with the y is right here at +1. So 2, 1 is the location of point B. And I can always connect 2 points on a coordinate plane. And if I connect 2 points and I draw a line or a segment or a ray, now I have what's called a slope. And a slope refers to the incline of this line. So how much does it go up and over? You can think of hills having inclines. Airplanes taking off have to take off at a certain incline. So this direction of incline, that's what we call a slope. And a slope is a ratio. It's a number that's a fraction. And usually we're talking about the rise, the y values, how much it goes up over the run, how much it goes left or right. This particular line, if I start at A and I move towards B, has a negative slope, and we say that that line falls. And we read lines the same way we read anything else, from left to right. And so from left to right, this line is going down, or it's falling. And it's falling at a certain slope. And let's figure that out. Well, if we have a picture, we can just count it. How much down does it go? 1, 2, 3 down. And remember, if it's going down, it has a negative rise. And how much does it go over from here? Well, right here, 1, 2, 3, 4. It runs 4, or it goes to the right 4 units. And when I'm talking about a slope, I usually refer to the letter m. And this is the letter that means slope. In our equations later, we'll see m. And we need to know that m is representing the slope of a line. So this line drops down 3 and goes to the right 4. We could continue the line if we just continue the slope. Let's count down another 3. 1, 2, 3, and over 4. 1, 2, 3, 4. And this is another point on the line. I know it's another point on the line because it has the same slope. And we could go on like this forever. 1, 2, 3, 1, 2, 3, 4. This is good enough right here. So this is all supposed to be one line here. There we go, kind of, sort of. Alright, so it continues to have the same slope because it's the same line. Now, if we don't know the slope, let's say we got some points here, maybe we don't know the units, I don't know why we wouldn't be able to count the slope. Sometimes we're just given coordinate pairs, and rather than have to draw a graph, we could just figure out the slope without having to draw it. Sometimes that's a little faster. Let's say that I was given 2 coordinate pairs, and I don't want to graph them, I just want to figure out the slope. Let's say I was given 3, 4, and -1, -2. So without having to draw a graph, I want to figure out the slope. Well, we have an equation that we can use. It's called the slope equation, and it's written like this. It says that if I take a y value and I subtract it from the other y value, so if I subtract these two y values, then I get the difference in the rise, or difference in the y values, and that's what rise really is. It's a difference in y values. And the run is represented by a difference in the x values. So it doesn't matter which pair you choose to be your first pair or the 1 pair, or which pair you choose to be the second pair or the 2 pair. I always just choose the first one for the first pair and the second pair they give me for the second pair. Or if it's alphabetical, I make A the first pair and B the second pair. But it really doesn't matter. As long as you just choose this to be your first pair and the other one to be your second pair, you could do it forwards or backwards. It works out the exact same way. So y2 is the y value from the second pair, so that's -2. And the y1 value is the y value from the first pair here. So I need to subtract those two values. And here's the second x value right here. And I need to subtract the first x value right here. That's the x value from the first pair. So I plug that in there. And let's do some math. -2 minus 4 is -6. And -1 minus 3 is -4. And sometimes we have to simplify a little bit. A negative divided by a negative, well, we know that's a positive. So I need to simplify that to positive at the very least. And sometimes we can reduce the fraction. And if we can reduce a fraction, we always have to. So 6 and 4 can be reduced. If I divide both of them in half, then I get m equals 3/2. And that's my slope. This is a positive slope, so it's going to go up from left to right. It's going to go up 3/2 in between every point on that line. And so that'll give me a positive slope, or a slope that goes up from left to right. It would look something like that. Alright. So that's enough of an introduction. In the next video, I'm going to talk about all the ways that we can find all of this stuff out, either looking at a picture or writing equations and dealing with those. So meet me in the next video.